Hello, Year 11s. So we're continuing on with space physics, and the next little bit that you need to learn is just about the solar system and gravity and orbits. Very short section, and I think most of you will probably have grasped some of this already. It's covered in the lower years in the school. Okay, first of all, the solar system. You need to know what the constituents are, basically, of the solar system, and be able to name the planets in order, that sort of thing. So just very quickly going through that, the solar system consists of a star, the sun, which contains almost all of the mass of the solar system. It's the dominant object in the solar system. Orbiting around the sun, you've got 8 planets, 4 inner rocky planets and 4 outer gas giant planets. Basically, the definition of a planet is that a planet is large enough to be round by its own gravity. It orbits the sun directly, unlike a moon, and it's also large enough to have cleared its own orbit of smaller objects. On top of the 8 planets, there are also at least 5 dwarf planets, including the ex-planet Pluto that was demoted in 2006. Now, the definition of a dwarf planet is that it's basically the same as a planet. It's round and it orbits the sun directly, but it's not large enough to have cleared its own orbit of similar sized objects. So Pluto, for example, orbits the sun in the Kuiper Belt, which is a region that includes lots of smaller objects but similar in size to Pluto. So it's not counted as a full planet anymore. On top of the planets and dwarf planets which orbit the sun directly, you also have satellites that orbit the planets rather than orbiting the sun. Now, there's about 150 natural satellites in the solar system, including the moon, which orbits the Earth. Jupiter and Saturn each have about 60 or more satellites each. Don't confuse them with artificial satellites, which are man-made objects, man-made spacecraft, which orbit the planets, mainly orbiting the Earth. But also we've sent a few orbiting the other planets too. So that's basically the main constituents of the solar system. So you've got to learn the names of the planets, and you've got to learn the definitions of dwarf planets and satellites. The only other thing you do need to learn about is the fact that the solar system is actually part of a much bigger system. The solar system itself is quite small in terms of the universe, but it's part of a much bigger system, a huge system of billions of stars. In fact, about 300 billion stars, all held together by gravity in a huge disk. And this is called the Milky Way. So the solar system is only a very small part of the Milky Way galaxy. The other thing you need to learn about is orbits and gravity. So how are things kept in orbit? And an orbit is a path that a smaller body takes as it moves around a larger body, such as the planets orbiting the sun or the satellites orbiting the planets. How that works is that gravity basically pulls any 2 objects with mass together. You've learned this before in physics. And if you've got a small object like a planet moving around the sun, basically the planet wants to move at 90 degrees to the sun. So if that's the sun, there's the planet. The planet is wanting to move this way. But at the same time that it's wanting to move in that direction, there is a force inwards because of gravity towards the sun. That will try and accelerate the planet towards the sun. But because the planet is moving in that direction, rather than the planet moving directly towards the sun, it will move in a curve. And as it moves in a curve, the direction of the force will change. It will always point inwards towards the sun. The result of that is that the planet will move in a circular path around the sun. Sometimes the force is called centripetal force because it's always pulling the object inwards. Anything that's moving in circular motion, by the way, is a similar thing. There's always a force pulling the object towards the central point. So that's basically how objects stay in orbit around a larger object. Gravity is pulling them in towards the middle, but they're trying to move at 90 degrees. The combination of that causes them to move in a curve. And that's basically all you need to learn about gravity and orbits. In the case of the planets orbiting the Sun, gravity gets weaker. The gravity from the Sun gets weaker the further out you get. And this explains why the planets take longer and longer to orbit the Sun, the further away you get from the Sun. So, for example, Mercury, which orbits the Sun at about a third of the distance that the Earth orbits the Sun, that only takes 88 days to orbit around the Sun. And the average speed of Mercury in its orbit is incredibly fast. It's about 47 kilometers per second orbiting the Sun. On the other hand, if you go out to Neptune, which orbits the Sun 30 times further away than the Earth orbits the Sun, Neptune moves really slowly around its orbit. Its average speed is only 5.4 kilometers per second. And that means it takes a huge amount of time to orbit around the Sun, 165 years to do one or complete orbit around the Sun. Not only is it has to move at a much greater distance because it's further out, but it's also moving much slower. In fact, Neptune's only done one orbit around the Sun since it was discovered. So that's basically it. That's what you need to learn. So this week, there are some notes that I want you to take down. I'll add them to show my homework. I'll also give you some links of stuff that you can read up, and there'll also be some homework, and that will be in for Friday. And that's it. Thank you.